Hello, in this video we are going to present the analysis of the service system at a university food point. The members of my group are Daniel Sanchez, Laura Melendez, Fernando Moreno, and Isabel Madrid. Initially, we tried to collect data from one restaurant, but we realized that this data was not sufficient to analyze the entire system because we only collect data from a single cash register in Maison de la Sabana. So when we try to calculate the arrival rate and the attention rate, we realized that a lambda was greater than mu, indicating that the system was collapsed. This is a crucial factor in quantum theory because for a system to be stable, the service rate must be greater than the arrival rate. For this reason, we decided to change our way of collecting data and take into account the entire process. And finally, we collect data from another university restaurant.
For queuing theory analysis, we chose to make our data recollection at Punto Crepes in Universidad de La Sabana. We wanted to focus in the same period of time on 3 consecutive days, so we chose 2 p.m. We focused on a single server with 1 queue. The methodology for this investigation was to record our data on an Excel spreadsheet with the customer arrivals, the waiting time in line, and the waiting time for their service to be made. So with this, we analyzed the different patterns in customer behavior, the waiting time in lines, and the service rate. We also had made some video recordings for backup for the investigation, and we consider this as an MM1 model because the service rates and arrival rates are exponential, and we only had a single server.
Okay, the results that we obtained was the average checkout time, the service rate, that is mu, and the arrival rate, that is lambda. Here we can see that the service rate is higher than the arrival rate, which indicates that the system can serve customers efficiently. We also analyze the number of customers waiting and in the system in general, the average number of customers in the queue, the average number of customers in the system. This means that on average less than 1 customer is waiting in line and less than 1 customer is in the system at any given time. We also calculate average time waiting in line and average total time in the system. On average, a customer waits about 1 minute in line before reaching the cash register, and the total time in the system from arrival to completion of the process is approximately 3 minutes. And finally, the percentage of system usage, P.
If there are more than 2 customers in the system, it is possible that the new customers will not enter in the queue. So we must ensure 95% of confidence that there will not be more than 2 customers. To achieve this, we need to improve the service rate of the counter from 43.47 customers per hour to 56.10 customers per hour, which represent an additionality 12.63 customers served per hour, preventing a student from choosing another restaurant or leaving the line. This will ensure a smoother process, reducing customers' wait time and improve the service.
Based on the analysis, we can conclude that Punto Crepes has a high probability of 10.87% of having more than 2 customers waiting, exceeding the target of 5%. This means that customers experience long queues, which negatively affects their experience. Our solution is that the service rate needs to be increased to 56.10 customers per hour. Currently, they are in 43.47. This will reduce the probability of excessive waiting to 5.01%. So our recommendation is to increase efficiency, reduce service time by 0.31 minutes per customer, optimize the process by streamlining the order taking and payments, and improve physical design of the service area, and custom monitoring where we measure and analyze the performance to ensure improvement and detect new problems.